Okay, so in 5.5, we're going to look at what are called the rational zeros of polynomials. And all that means is our zeros that are going to come from the polynomial in factored form will be rational numbers. Rational numbers are numbers that can be written as fractions. So they're pretty much the numbers we've been seeing every day, like, you know, +2, +3, -4 would be these zeros. They could be fractions because that's what a rational number is. So any polynomial we get that we're going to work with should be able to be factored all the way down. Now, this is the polynomial in factored form. This would be the polynomial up here if we multiplied it out. So how do we factor polynomials with a higher degree than 2? Well, look at one thing I want to show you. I mean, you know, the basic concept of factoring still holds true. If I look at -2 times -3 times +4, I get 24. The problem is there are lots of different combinations once we get above 2 factors. I mean, this could be -2. This could be +3, and then this could be -4. So you could be there all day trying to figure out the proper combination. But it still holds true that the constant terms still have to be factors of this constant term. You know, if I start with x cubed, that still means that I need to have x times x times x to get the x cubed. It can just get very complicated if you try to do it trial and error. I mean, you could be there for hours. So we test factors of the constant term to see if they are zeros using synthetic division. That'll save us time. So again, for the above polynomials, you know, the numbers 2, 3, and 4 are all factors of 24. We test positive and negatives. And what we can say is every zero has to be of the form what we call P divided by Q, where P is a factor of the constant term, which would be in this case from the above example would be the 24. Q is a factor of the leading coefficient. Well, our leading coefficient here is a 1. So therefore, we only need to look at factors of the constant term. And again, we must consider positive and negative factors of both terms. So what we're going to do, we're going to use our synthetic division we learned in R6 to factor these polynomials completely. Keep in mind that once your quotient is a square, a quadratic expression, you can factor like we've always factored. So let's just for one figure out how do we figure out what are potential zeros of a polynomial. So since our leading coefficient is 1 here, we only need to consider factors of the 2. So our potential zeros are factors of 2. That's what we're looking at. Factors of 2, which are going to be +2, -2, +1, and -1. Well, instead of writing it like this, we just say +-2, +-1. Okay, so those are when we're looking for just what are called the potential. We're not going to try to factor this or test them. I just want you to understand how that you find these. Still the same way we've always found them, any factoring we've done. What's different here in example 2 is we have our constant term, which is the 8, and we now have a leading coefficient of 3. So my potential zeros are going to be factors of 8 combined with the factors of 3. So this would give me plus minus 1, plus minus 2, plus minus 4, and plus minus 8. These are all factors of 8. See, that's the problem when you think about factoring these. You've got lots of combinations. Now, we're going to pair this with our factors of 3, which are just positive negative 1, positive negative 3. So this is going to give us way more, or I should say many more, possible zeros to test. Because what I have to do is I have to take every numerator with every denominator. The good thing is a lot of these will end up repeating themselves, but it's a long process. So my potential zeros are going to be 1 over 1, which is just 1. Positive 1 over 3 is just plus or minus 1/3. So you don't need to list all these things like plus minus 1 over plus minus 3 because the plus minus are kind of interchangeable. Then I go with the 2. 2 over 1 is 2. 2 over 3 is 2/3. 4 over 1 is a 4. 4 over 3 is 4/3. Lastly, 8 over 1 is positive 8, plus or minus 8. Then 8 over 3 is plus or minus 8/3. Now, that's a whole lot, I know. These are what's all possible. Not saying that you're probably only going to have at most 4 because of the 4th power, but you have to know what your possibility are when you're thinking about, you know, these combinations. And what makes it so many is that 3 right here. That's what increases the number of potential zeros. Just like when we factored quadratics, when we had a 2x squared or a 3x squared, you had many more possibilities. Same way. Now, it doesn't mean you actually test all these. What this just means are these are the possible numbers. Normally, you know, what I would go with are the integer types, the 1, the 2, the 4, and the 8. Hopefully one of those work before you actually have to get to the fractions. Okay, so that's just how you list your potential zeros. Now let's look at where we're asked to find the rational zero. So there's a difference between the potential and finding the actual one. So in this case, we have to take this polynomial and we've got to write it in factored form. So the first thing I do is I look at my potential zeros, and they are just the factors of 4. Because I do not have a leading coefficient here, I just look at factors of 4. And so these are plus minus 1, plus minus 2, and plus minus 4. So next, I use synthetic division to test zeros. Okay, so here's where you need to be organized. Don't be jumping around. Start with positive 1. If that doesn't work, go to negative 1. Go to positive 2, negative 2, and so on and so forth till you've either exhausted all of them or you find a 0. Okay, so when I set up my synthetic division, I'm going to try 1 as my potential 0. I list my coefficients. I've got 1x cubed, I've got 3x squared, I've got 0 x's, and I've got negative 4. So be careful there. You know, if you forget this 0 for your missing x term, then you're in big trouble. And you'll be there for a long time. Okay. Bring down the 1. 1 times 1 is 1. Combine like terms to get 4. 1 times 4 is 4. Combine like terms to get 4. 1 times 4 is 4. And I have a remainder of 0. So from what we did in R6, remainder is 0. One is a 0, and x minus 1 is a factor. This is all of what I know about when I get that 0 as my remainder. So x minus 1 is a factor, and my quotient is x squared minus 4x plus 4. Again, I get that from this is my remainder, my constant term, coefficient of x term, coefficient of x squared term. All right, so what's this tell us? I'm going to flip over here. So what I know is x cubed plus 3x squared minus 4 equals x minus 1 times x squared plus 4x plus 4. That's what I know. That's my first round of factoring. I've taken out one factor, and now I'm left with a quadratic expression, I should say, excuse me, and I can factor this again using the FOIL method. So you don't have to use your synthetic division. You certainly can use synthetic division, but hopefully we just remember how to do our FOIL method. That's the way we factored forever. So this is completely factored, and we can take this one step further and say this is x minus 1 times x plus 2 squared. So this is kind of like taking us back to what we did in 5.1, where we graph these things. Your zeros, are 1 and negative 2. Touches here, crosses here and touches here based on the powers of your factors. Okay, so we've come full circle to what we started with in Chapter 5 with the polynomials already in factored form. And this is what we end up with. And, one thing you can look at again is, this is negative 4. And if I took negative 1 times 2 times 2, I get negative 4. So it still has to work out that way. Okay. And so there you go. You've got one example there of factoring. And my quotient. I gotta pay attention to what I'm doing. Sorry about that. Your quotient over here is x squared plus 4x plus 4. I start talking, not paying attention to what I'm writing. So go back and change that, so you don't look at the next page and wonder how in the world I got the plus 4x. All right. Okay, let's look at another example. So here, again, we're just going to find the rational zeros. The difference now, we have a fourth power. So if you think about the first step we do with our synthetic division, we're going to have our quotient will have a third power. So this means we will have to do synthetic division twice. So I'm still going to look at my potential zeros. And again, since we have 1x to the fourth, we're just looking at factors of 12, which are positive, negative 1, 2, 3, 4, 6, and 12. And that's just something you got to know. Okay, you can't randomly just be testing, 5, 7, 8. You got to test the factors of this number here, of your 12. More than likely, most of the time, 1, negative 1, 2, or negative 2 is going to work. Not always, but most of the time, it's going to be one of these. So if you go through 4 rounds of synthetic division, testing 1, negative 1, 2, negative 2, and you didn't get a 0, I would go back and double check your signs to make sure everything's in line, because normally one of those are going to work. All right, so first let's try 1. Now my coefficients are all good. I have x's all the way down, so I do 1, 4, -1, -16, -12. And again, this is something where you may need a lot of space for, because it may not work the first one. So I bring down the 1, and I just go through my process. 1 times 1 is 1, add 5. 1 times 5 is 5. 5 minus 1 is 4. 1 times 4 is 4. -16 minus 4 is -12. 1 times -12 is -12. That gives me -24. So no, 1 is not a 0. Now I try -1. You know what I like about this is it's just a big puzzle when you're trying to find a solution to the puzzle. A lot of people don't look at things like that, but I do. All right, -1 times 1 is -1. 4 minus 1 is 3, so please watch your signs here. -1 times 3 is -3. Add these together, signs are the same. I get -4. Multiply again, -1 times -4 is +4. Still gives me the -12, but the good thing here is when I take -1 times -12, I get +12, remainder of 0. So I get yes. So -1 is a 0. X plus 1 is a factor. All right. So I now know that P of X, which is this, okay, which is what we started with, is going to be X plus 1, and my quotient, again, comes from down here. So my quotient, and I'm going to write this down here, is x cubed plus 3x squared minus 4x minus 12. That's my quotient, which comes from right here. So I take this times x cubed plus 3x squared minus 4x minus 12. All right, I'm just going to flip this over to the back side, because now what we need to do is we need to now factor this. Now this can be factored by grouping. Some of y'all may remember how to factor by grouping, but I'm just going to keep working with the synthetic division, which gives you one method to do everything. Okay, don't go back and do synthetic division again on the original, because you don't know really when to stop. Okay, and you may never be able to find that last one. It may take you forever. It's much better to break it down step by step, because once I can factor this doing my synthetic division, then I can do my FOIL method. So it's going to save you time. All right, so I've still got P of X equals X plus 1. So I better watch my signs here. X cubed plus 3x squared minus 4x minus 12. Again, I'm going to check that just to make sure I don't screw up a sign. Y'all know how I do that. All right, so since I'm still have a 12 here, I'm going to test the same possible factors, the same zeros I tested. We know 1 is not a 0. Positive 1 was not a 0. We found that out on the first one, so it's out. But -1, okay, could be used twice, so I better rule it out, and I'll try -1 first again. 1, 3, -4, -12. I mean, this really is fun. You got to admit. mean, one thing it's not, there's no X's, it's just a numbers game. So it's kind of like a Sudoku puzzle, all those things. So, come on, have fun with it. So bring down the 1, multiply. 3 minus 1 is 2. Negative 1 times 2 is negative 2. Negative 4 and negative 2 is negative 6. Positive 6, negative 6. So no. So I'm done with negative 1. Move on to 2. Bring down that 1. 2 times 1 is 2. That gives me a 5. 2 times 5 is 10. 10 minus 4 is 6. 2 times 6 is 12. 0. Yay. Okay. Yes. So 2 is a 0. X minus 2 is a factor. Okay. That's what I know. So now what I am left with, P of X is the X plus 1 now times X minus 2. My quotient after this round of synthetic division is X squared plus 5X plus 6. So that goes here. Okay. Now I'm down to my quadratic equation. I can factor doing my FOIL method. So factors of 6 that add up to be 5. Everything's positive. So that right here are factors of this. So then my zeros, negative 1, positive 2, negative 3, negative 2. Okay? So, these are some of your examples. It can take a while. I mean, you may have to, like I said, you may have to do 3 or 4 synthetic divisions, but if you get good at it, they don't take you that long. You got to make sure you practice it, though. Okay, you just got to make sure you practice it till you get good at it. All right, this last example here, we do have a leading coefficient of 2. So your potential zeros here are factors of 6 over factors of 2. And this is positive negative 1, 2, 3, and 6 over positive negative 1, positive negative 2. So here's where we form our fractions. And we go 1 over 1. So my potential zeros are going to be positive negative 1, positive negative 1/2, 2 over 1, which is 2. 2 over 2 is 1, but I already have that, so I don't need to list it again. 3 over 1 is 3. 3 over 2 is 3/2. 6 over 1 is 6. 6 over 2 is 3. I already have that. So here are my potential zeros. Now, again, I'm going to try 1, 2, 3, and 6 before I go to 1/2 and 3/2. So I'm just going to try 1. My coefficients are 2, 11, negative 7, negative 6. All right. So I bring down that 2, go through my process. 1 times 2 is 2. 11 plus 2 is 13. 1 times 13 is 13. 13 minus 7 is 6. 1 times 6 is 6, and that gives me a 0. Yay. So that's my remainder. So 1 is a 0. X minus 1 is a factor. And my quotient is 2x squared plus 13x plus 6. So these type of quadratics, so if we look at what we have left here, we have p of x is now x minus 1 times 2x squared plus 13x plus 6. You know, if you multiply this out, again, we would get what we started with. And this is the type that many people have trouble factoring. So just do synthetic division again, okay? You know, I mean, it might take you a while, but that is an option. But what I'm going to do is I am going to factor this. So remember, you know, I know it can be factored because 2 times 6 is 12. Factors of 12 that add up to be 13 are 12 and 1. So therefore, I know that I have to get 2x and x here. Think about 12 and 1. So if I take 1 times 1, I get 1. If I put a 6 here, 6 times 2 is 12. I get the factors I need. So, my zeros. Well, I know this is a 1. Be careful here. 2x plus 1 equals 0. 2x is negative 1, so x is negative 1/2. And this one here is negative 6. So, my zeros are 1, negative 1/2, and negative 6. So going back up here to our potential zeros, well, there's plus or minus 1/2. So it would have been a 0. But luckily we got it from factoring, because if you think about going through the process of synthetic division using this, you would have tried 1, negative 1, 2, negative 2, 3, negative 3. Finally, you would have got to 6. So it would have taken you a while, okay, till you got to the negative 6. Once you would have got the negative 6, then you would have known the 1/2, but that's okay. So still try to factor that. All right, so we will pick up with this in class and do more examples then.